So, camera just cut out. Sorry about that. Free Bandicam. 10-minute max. Back to this subject. It'll take a really long time to create this temporary table because it actually has to go through all million records, pull out the first name of everybody, and then put it in the new temp tables binary file. And so that's kind of a long process. It's sped up a little bit by having the data buffer and loading things in chunks and storing them in chunks. Actually speeds it up a lot. But still, it's slow enough to where I don't want to do it on this gigabyte table because it's not worth waiting for. So let's just close this table. And then we can hopefully load my copy of it. I don't know, I haven't tried loading it yet. Okay, cool, that loaded perfect. Okay, so this table is 0 megabytes. It's something in the kilobytes or just the byte range, so it just says 0. And then we got total records 40. And so let's just select star from info1. And that'll print out all 40 records. Like I said before, no temp table because we just selected the whole entire info table. So there's no reason to make a temp table. But now if we do select age, comma, first name from info, then it'll create a temporary table. So this is a whole new file, a whole new binary file inside a folder called temp that has its first column as age and its second column as first name. And then when you select like age first or you select first name first, it'll sort the whole list by that name or by that selection. So since we selected age first, it sorts it by age. And as you can see, it's actually sorted by age, which is pretty cool. And so we have one extra command down here now. Because it's a temporary table, it gets overwritten anytime you make a new selection. So there's a command that says save temp as, and then you give it a table name, and it should save it into the database. Unfortunately, I developed this project in just a couple days and didn't have time to fix the bugs that make this command crash. So it doesn't actually work. So let's select info, or select, did close, load, what else is there? Ooh, I really should have created a help command so I could see all the commands. Here's my actual command parser that does the command parsing. It's a state machine that uses a 2D array. The actual 2D array is located in the class file or the CPP file. Yeah, here's the actual 2D array that defines all the commands. So yeah, we have the command select, the command create, load, rebuild. Rebuild will rebuild the index trees because I don't even know why. Sometimes you might mess them up. If you mess up the actual files, like the index tree files, you can rebuild them from scratch. Just takes a little bit of time. And then insert. Oh yeah, we haven't actually covered insert. That's kind of important. Okay, so if we want to insert into info1, all we got to do is type insert into info1 values followed by all three values. And there we go, inserted record. And if we do select star from info1, we can see Andrew Minor 20. Actually, it's down here. There's two of these. When you insert, it inserts into the bottom of the table. It doesn't insert sorted or anything like that. So it went to the bottom. Alright, now that we're done with pretty much the whole application, and we can close table info and then exit. Here's a quick look at the actual files themselves. Here's the database creates this folder and the subfolders. So you have a database folder, temp, where the temp stuff is stored. these are the index tables for the temp. Like I said, these don't actually get created, so they'll always be 13 bytes, and like they're just empty objects that it creates by default, and I didn't bother removing that functionality. And then here's the actual table folder. Ignore these objects; these are just like our copying stuff that I was messing with. But it creates these folders, and like here's the info table, and then here's the actual record file, which is a gigabyte. And then we have the index tables. And the index tables are significantly smaller size because they hold much less repetitive data. Like anything that's repetitive doesn't repeat in these index tables, if that makes sense. Probably doesn't. But if we edit these with Notepad++, and we actually, this one's too big. My bad. Let's go to this one. Edit with Notepad++, and then we can switch to the hex editor. And here we can actually see the record files. And so here's the very first record in the table class. This is where it starts. Or it actually probably starts somewhere like here. Because the records begin with the counts of how many records there are. Or how many columns there are in the record. And so this is probably 3. I mean, it's not 3. This is not the right hex number for 3, but I'm not exactly sure where it is in this. It's kind of hard to read. But here's the actual column values of the first record. Andrew, my name, and my last name, my age, and then you have all this empty data. And it's because the reason all this is empty and there's not another record immediately following is because the records have to be fixed sized in order to write to binary file. They don't necessarily have to be a fixed size, but to keep it simple, they have to be a fixed size. So it's like a 2D array of, or an array of C strings, you could say. And so these are all just the empty fields that don't need to be used because there's only 3 columns in this table. And so yeah, it makes the table files a lot bigger, but only way to fix that is to have more time. And then here's the next record. And yeah, so this is just a consecutive list of records for the record file. And then here's an actual index table. And if we can view this in hex, this is a lot more jumbled. You can't really read the hex file of this. You kind of just got to understand the structure. But yeah, that's what the hex files look like. And that's where all the data is stored, and all the sorted data is stored. And yeah, I think that's it. I had a decent time working on this project. It was kind of cool working on the D+ trees, although I'm not happy with how slow they are. Even though they're pretty fast, I really need to get the internal nodes to stay loaded in memory instead of having to read the internal node and then delete it, and then read the next one and then delete that one. It'd be nicer to have all those in memory. But thanks for watching. I hope you got something out of this video. Maybe you're trying to make your own database project, and hopefully this helped you. Alright, bye.